Hello everyone, let's start with the next problem of module 3 symmetrical components. The problem is like this: the positive and negative sequence components of phase voltages of three-phase system is VA1 is 230 and VA2 is 60, and then we determine the positive and negative sequences components line voltage and the line voltages. So already we discussed, derived the equation where VA1 is equal to VA1 is equal to J root 3 VA1. This is a positive negative sequence component, J root 3 VA1. Just to substitute the values of VA1, this value, and then we get the value like this. And if you want VA2 minus J root 3 J root 3 into VA2, and the VA0 is equal to 0. Just by seeing the question, we can say zero sequence components where the value becomes 0. And if you want to calculate line voltages, that is positive voltage, negative line voltages of three lines, that is VA is equal to VA0, VA1, VA2. Already we calculated from the previous slide, so just to substitute, we'll get the values like this. And then if you want to calculate VB, this is a formula, and we can find out, and VC is equal to this value, we'll get it. Okay. So let's solve the derivation, relationship between sequence components, phase and line current in delta connector system. Consider delta connector system. This looks like a delta, as you know that this is a delta. This is a delta connected system. So having line currents of IA, IB, IC I show in figure. This is the ABC, as you can say RYB also. So the branch current ICA, IB, IAB, IBC shown as Z is the impedance. So if it is a balanced, this impedance values are equal, and then phase difference also equal. Let's start with the diagram. The phase current delta winding IAB, IBC and ICA, let us designate IAB is equal to IC, IBC is equal to IA, and then ICA is equal to IB. Already we solved this problem, voltages we solved. IA is equal to IC minus IB, IB is equal to IA minus IC, IC is equal to IB minus IA from the previous diagram. If you want IA is equal to IC minus IB, so see here, the apply loop equation, KCL to the node IA and then IB and IC, you'll get the equations like this. The sequence components current like this: IA1 is equal to 1 by 3 IA plus IA1 IA IB IA square IC. So finally we got the equation. IA1 is equal to J root 3 IA1. Already voltage also VA1 is equal to J root 3 VA1 we got, and similarly for negative sequence component, IA2 is equal to minus J root 3 IA2 as usual. We got same thing. So similarly, zero sequence components is become 0, right? 0. IA0 is equal to 0 we got. Just to substitute these values over here. And next we have this is the equations we have, and then we'll solve the problem. We solve the problem of one question. So the question is like this: in a three-phase, three-wire system, the line current R IA is equal to 100 angle 0 degree A amps, and then IB is equal to 100 angle minus 100 degree amps, and then determine the sequence components of line currents. The three-phase three-wire system, so the equation is IA plus IB plus IC is equal to 0, IC is equal to minus IA plus IB. So they have not given IC value, you can calculate IC value. Okay. IC we got all the values, all the sequence components we got. So IA0 is equal to 1 by 3 IA plus IB plus IC, and IA1 is equal to 1 by 3 into IA plus IB plus I square IC. Just to substitute the values, you will get the solution for the question. So IA1 is equal to next problem we have. A balanced delta connected load is connected to a three-phase symmetrical supply. The line currents are each 10 amps in magnitude. If fuse is in one of the lines blows out, determine the sequence components in the line current. So IA is equal to 10 angle 0 degree, and C is open. I mean, if it is dies out, we need to calculate that value. IB is given 10 angle 180 degree. How to calculate this sequence component? So since there is a three-phase three-way system, they have IA plus IB plus IC is equal to 0, and IB is equal to minus IA. IC is equal to 0 because the fuse is blown off. I mean, the fuse blows out. So IA is equal to 10 angle, IB is equal to minus 10. So minus 10 you can write 10 angle 180 degree. So hence the positive sequence component. So IA1 positive sequence component, the formula is 1 by 3 IA plus AIB plus A square IC, where IA is 10 angle 0, and then AIB 10 angle 180 degree, and then A square IC 100 degree into IC is 0. IC is 0, and finally we got the value as 5.78, and this one value. IA2 is 1 by 3 A angle 0 degree, A square 10 angle 180, and plus 240, because A square is 240, plus 240. We got the equation as 5.78 angle 30 degree. IA naught is equal to 0. So IA naught is equal to 0. So this formula is very much important, right? So IA naught, IA1, IA2 is equal to 1 by 3 into 1 1 1 1 1 A square A IA IB IC A square, IA1 A square, and then A. This is very important for solving the problem. Okay, so if it is this one is a sequence phase sequence components in terms of phase current. Okay. So thank you so much for watching my video, and let's move on to next problem.